Okay, what about mean response? So there's something else that might be of interest, and that's predicting values or predicting the mean of new values. So what's a confidence interval for the predicted y, the mean of y, and when x is equal to some value? So in our oxygen example, right? We got these points. We could fit a line to them, and we could say, well, what do I expect the oxygen purity to be if my hydrocarbon concentration is 1%? All right, I'm going to set hydrocarbon concentration to 1%. What's the predicted y, and what's the confidence interval for that prediction? So I've got some more formulas for you now. Turns out that if you plug in, because beta hat naught is unbiased and beta hat 1 is unbiased, we can use the line as an unbiased estimator of the true mean y when x is equal to 1, or any other value. As before, if this is going to be normally distributed, the point on the line, the predicted value on the line, is normally distributed because it's a linear combination of normal variables, if our assumptions are satisfied. And there is a bit of work in showing that showing that the variance of this prediction is sigma squared times 1 on n plus x minus x bar squared over sxx. So this gives us a slightly more complicated formula than before for the standard error. As before, we replaced sigma with s, which was estimated with n minus 2 degrees of freedom. So our statistic now has a t n minus 2 distribution, giving us a confidence interval for the mean response when x equals some value, whether it's 1 or whatever. And so we can go crazy using this formula to construct a confidence interval for the mean of y at any particular value of x, or you can use the predict function on MATLAB. Most software is able to come up with predictions with confidence intervals around those predictions. And so, just be aware that you can always do this using software instead of using the messy formula.